Hello, everyone. Today we are going to continue with the quantum physics topic. Last time we already discussed about some issues by the classical physics that cannot be solved. So let's recap what are the four issues by the classical physics that make classical physics collapse. Okay, so let's have a look. These are the four issues. Number one is the atomic spectrum of hydrogen, where when we know that, for example, if we burn the hydrogen atom gas, what we see, the hydrogen will emit this certain light spectrum. So scientists will ask, why this few light spectrum only? Why is it not continuous spectrum? Is there any trend? Ada tak corak-corak formula ke to know the next one? For example, next one is helium. What is the wavelength that of the light that can be emitted? Okay, so this is the first issue that they wonder why is it discrete? Why is it like single line? Why is it not continuous? Okay, so second is about black body radiation. Black body, we know that black body is like a perfect ideal body that can absorb all the electromagnetic wave. So all the energy can be absorbed. So we might think that this black body will soon become more and more energetic until it explodes. But actually, it's not that way. For example, the sun. Sun is a good example of black body where it can absorb all the electromagnetic wave. But the thing is, at the same time, it can emit this thermal radiation, okay? Because you want to balance the energy within itself, or else it will get explode. So it will emit this thermal radiation, we call it black body radiation. So when when the experiment is done to this black body, so what they found is this is the curve. When we see the curve here, it is like going up and then going down. So according to classical physics, if the temperature is higher and higher, what we see, right, okay, as the temperature getting higher and higher, so the energy should be higher and higher also. There should be no limit to the energy. All right. That means the higher the temperature, the higher the energy that we will see. But we see here in this uh ultraviolet, okay, ultraviolet wavelength, all the values almost like drop. So that's why we call a phenomena as ultraviolet catastrophe. That means malapetaka ultra ungu. It means ultraviolet is the maximum. Until that, and then the energy will go down. So why? Again, classical physics cannot explain. We know that temperature increase, the atoms get excited, so energy should be increasing. But why until certain level, or certain wavelength of the frequency, it will drop? Okay. And number three is a photoelectric effect. And this effect actually is by accident. Okay, why I say by accident? Because at that time, they want to prove the existence of electromagnetic wave. So they tried to do experiment, and then the thing is they found that the spark, okay, when you actually emit the electromagnetic wave, for example, any EM wave lah, okay, they found that the spark can be produced. So this spark means that there's something coming out from the metal. Okay, there's something coming out from metal. So they might ask why when we shoot a electromagnetic wave to the metal, so something can come out. Uh, it's like this thing come out can conduct electric current. Okay, it's like something like electron that can conduct the electricity and so on. So the question, okay, why this photoelectric effect happen? And the thing is, This does not depend on the brightness of the light. The brightness. That means, for example, if I up the intensity of the light, if I use the low frequency, okay, if I use the low frequency of light, so nothing happened, even though I put it in the brightest level. But if I use a very dim light, okay, dim light, but the frequency is very high, eh, we can see something happen. So that means this photoelectric effect is not depending on the intensity, but it depending on something else. That's what they want to investigate. Just like you imagine, if I ask you to carry a table, you cannot carry a table. So you ask your friend, two people, three people, come and carry the table. So you in classical physics, you know that uh tables can be carried if we have more people, because with more force, more energy, right? But in this quantum physics, they don't say like this. Uh, it's like you want to carry this table, it's nothing to do with the number of people, but it's something to do with the age. For example, if you want to carry this table, you must be at least 30 years old. Sounds weird, right? So if let's say the first person come, your age 9 years old cannot. Second person come 30 years old, okay, you can carry them. So similar to this photoelectric effect, when we have a certain requirement for the EM wave, then something can be, yeah, emitted out. The photoelectric effect can happen. Okay, that's number three. And the last one is the stability of atom. So I believe you will learn about chemistry, the how is the atom inside here we have subatom, nucleus, we have the proton, neutron, electron, right? We learn about J.J. Thomson, Rutherford, and then Niels Bohr, right? So the thing is, uh we know that this atom, the electron, when he will emit the electromagnetic wave. Okay, so when it emit the electromagnetic wave, the energy will be emitted. So when energy decrease more and more, so what happened to this electron? This electron will be less energetic. So it cannot, it's supposedly, according to classical physics, it cannot keep orbiting. It will lose energy and slowly it will be pulled to the center, pulled to the nucleus, and it hit the center of the nucleus, and then bam, the atom will collapse. But this is not what happened in it as what they observe. Again, classical physics cannot explain why. Why the atom still can be stable. So these are the four issues why we have the new era of physics, which is quantum physics. And for the next video, we'll talk about uh, a little bit what is the important point of the quantum physics.